Hi class, in this video we continue in chapter 2. We're going to move into section 2.6, and what 2.6 is titled is reviewing properties of equality and writing what we call two-column proofs. Now we have two objectives in this section. The first is we want to use properties of equality to justify reasons for steps. Okay, so like why we're doing things we're doing when we're solving problems. And then the second thing we want to do is we want to write two-column proofs. Now this will be a little tricky, and I'll hopefully in my two examples that I have for this show you what I mean by a two-column proof and how to make a really good argument. All right, so let's review some algebra properties of equality. Now you should definitely on your own have these printed out in your notebook or have them easily buy for reference because there's a lot of properties. So they begin like this. If we let A, B, and C be any real numbers, we have the addition property, which means if A is equal to B, then obviously A plus C is equal to B plus C. It just means you can add a constant to both sides of the equal sign. Same thing with the subtraction property. If A is equal to B, then A minus C is equal to B minus C. You can subtract the same quantity from each side. The multiplication property, if A is equal to B, then A times C obviously has to be equal to B times C. So you can multiply both sides by the same number. Same thing with the division property. If A is equal to B and C is not equal to 0 because you can't divide by 0, obviously, then A divided by C is equal to B divided by C. Same thing. All right, the reflexive property. All this means is A is equal to A. So if someone comes up and says something like 5 is equal to 5, that's a true statement. All right. The symmetric property, if A is equal to B, then obviously B is equal to A. All right, same deal, like X is equal to 5 is the same argument as 5 is equal to X. The transitive property, this is a really important one. If A is equal to B and B is equal to C, all right, notice how the B here is the end of one statement and the B is the start of the next statement, then A is equal to C, all right? This was equivalent, basically, if you want to think about it, to in the previous section, kind of like the law of syllogism, but this transitive property is more for algebra. All right, the substitution property, if A is equal to B, then B can replace A in any expression, right? So like if you have X is equal to 5 and Y is equal to 5, you could replace the 5 and have X is equal to Y. That's really what that's saying. All right, we have a distributive property. So you can use multiplication, distribute A to each term of the sum or difference within parentheses. So if you have A times B plus C in parentheses, you get AB plus AC. And it's the same thing over here. A times in parentheses B minus C, you get AB minus AC. This you probably remember from high school very easily, but this is called the distributive property. All right, so let's take a simple example here, like 5x plus 12 is equal to 47. And let's solve it, but what I want to do is I want to give a reason to justify each statement or each step. So you'll see what I mean by this reasoning. All right, and you're going to notice it's going to look kind of like a two-column thing. So here I have my statements, right, and the reasons. So I'm going to start with 5x plus 12 is equal to 47. The reason I have that is because it's given. Next thing I'm going to do, I'm going to have 5x equals 35. How did I do that? I subtracted 12 from each side. So that's the subtraction property of equality, that previous one. If I go back, forgive me, that's this. I subtract from each side. That's how I got there. That's called the subtraction property. All right, so next thing I have to do, I'm going to have to obviously divide both sides by 5. Well, that's just the division property. So all I did was do my steps and have my new statements. And what I do is I have to give a reason for this. So this is kind of like our introduction to two columns, okay? What I'm doing and the reasons I'm doing it. All right, let's do another one. Let's solve 7x minus 10 times 5 plus 3x is equal to 2x and give a reason to justify each statement. All right, so two parts. Pardon this little typo here. So I have my statement. So my original one, 7x minus 10 times 5 plus 3x equals 2x. That's given. All right, first thing I'm going to do is I'm going to distribute the 10. Name the property. I use the multiply or distributive property to do this. The next thing I'm going to do is I'm going to simplify or combine like terms, like 7x minus 30x is minus 23x. The next thing I'm going to do I'm going to add the 23x over here. Well, that's the addition property. And finally, I'm going to divide by 25, get x is equal to -2. That's just the division property. So it's doing this algebra that we definitely know how to do or remember how to do from high school, and it's just literally saying, well, this is the property I'm using to do this. This is how I'm justifying my steps. All right, there's some other properties of equality. All right, being a geometry class, we want to talk about with angles and segments. So the reflective property, if you have the measure of angle A, well, that's obviously equal to the measure of angle A. Line segment AB is equivalent to line segment AB. If you have the symmetric property, the measure of angle A is equal to measure of angle B, well, then obviously measure of angle B is equal to measure of A. Flip is true. If AB is equal to CD, then segment CD is equal to AB, symmetric property. And then that transitive property, that's an important one. If the measure of angle A is equal to measure of angle B, and measure of angle B is equal to measure of angle C, well, then obviously the measure of angle A is equal to the measure of angle C. So if the ending and starting are the same, the two on the end must be equal. Think about it that way. And it's the same with segments. If segment AB is equal to segment CD, and CD is equal to EF, then obviously segment AB must be equivalent or congruent to EF. All right, I'm going to give an example here. All right, so let's fill in each blank with the reason to justify the statement. All right, so I have this statement. CG is equal to MN. Well, MN is equal to CG. Well, that statement is just the symmetric property of equality. If I go back, that's just this part right here. Measure of angle A is equal to measure of angle B. Measure of angle B is equal to measure of angle A, or the flip with the segments. They work both ways. Here, so the second one, measure of angle P is equal to measure of angle Q. That's given. Measure of angle Q is equal to measure of angle B. That's also a given statement. So how do we conclude that measure of angle P is equal to measure of angle B? Well, that's just that transitive property. Notice how the end and start are the same, so these two must be the same. All right, measure of angle 1 plus measure of angle 2 plus measure of angle 3 is equal to 50. That's another given one. Measure of angle 1 plus measure of angle 2 is equal to 43 degrees. How is it that 43 degrees plus measure of angle 3 is equal to 50 degrees? Well, that's just the substitution property. All right, what you're saying here is, I know that measure of angle 1 and measure of angle 2 from up here, I can substitute it right in and get 43 degrees. So 43 plus measure of angle 3 must be 50 degrees. All right, so you're just using kind of the same properties as the algebraic ones with your geometric ones. All right, so I want to do some examples of writing a two-column proof now. So a proof is an argument that uses logic to establish the truth of a statement. There are many formats for proofs, but for now we will use these two-column proofs, right? So a two-column proof lists numbered statements on the left, just like how we were, let me go back, doing here, numbered statements, 1, 2, 3, 4, 5. So numbered statements on the left and corresponding numbered reasons or justifications on the right. These statements show a logical order of the proof. All right, so let me do some examples of this. So here's writing a two-column proof. Write a two-column proof. All right, so what we're given is that measure, I have this angle-looking thing, and measure of angle 1, which is right here, which is BAC, is equal to the measure of angle 3, which is EAG. So what I want to prove is that measure of angle BAG is equivalent to the measure of angle EAC. So really what I'm saying, and listen to how I'm going to justify this. The measure of angle 1 plus the measure of angle 2 has got to be the same as the measure of angle 3 plus measure of angle 2. So that's where we're going to go. All right, so make sure the figure is marked with the given information. Here, what I'm doing here, sorry, study what you want to prove and form a plan. I just told you what my plan was, right? So for example, since measure of angle 1 is equal to measure of 3, we can add measure of angle 2 to both measures of angle 1 and 3. All right, that was my plan. The resulting angles are the angles we are interested in, and we'll have equal measure. All right, so here's how we'll start. Start with the given statement. Measure of angle 1 is equal to the measure of angle 3. All I know that measure of angle 2 is equal to measure of angle 2, obviously. Now, what property was that? That was the reflective property of equality. Now what I'm going to do is I'm going to add it to both sides. So the measure of angle 1 plus measure of angle 2 is equal to measure of angle 3 plus measure of angle 2. All right, this was the addition property of equality. Well, measure of angle 1 plus measure of angle 2 was that measure of angle BAG. Measure of angle 3 plus measure of angle 2 is equal to that measure of angle EAC. All right, that was just the angle addition postulate. All right, so when you add two together, they get this. So then, knowing this, the measure of angle BAG must be equal to the measure of angle EAC, and that's just the substitution property. I'm literally going back up into here, measure of angle 1 plus measure of angle 2, whoop, substituting that right in there. Measure of angle 3 plus measure of angle 2, whoop, substituting right in there. All right, you're going to get a chance to read about this and practice this. These are very confusing, but give it a shot this week in your homework and in your journal assignment.